Okay, so we are now in the most important part of engineering economics, and this is economic evaluation process. That's why I was saying a while ago that if we are not going to take up this topic as if you did not enroll in engineering economics. So the past, approximately 9 weeks previously, that is only learning the different tools in engineering economics. Actually, the actual engineering economics starts from here. So it is about evaluating engineering projects. But of course, those knowledge that you learned from the previous chapters are very important. First, we are going to deal with time value of money here. So, chapter 2 is very important. And of course, we are going to estimate, we are going to project the future. That's why you need also the topics in chapter 4, because in order to estimate or to predict, we need to use the historical data in the past, and you know already how to get the average inflation rate, general inflation rate. So if you're going to estimate or predict, forecast the future for your future projects, you can use those knowledge that you learned from chapter 4 about projecting, about estimating, and so on and so forth. Okay, remember that engineering economics is futuristic. So we estimate the future because most of the projects are going to be implemented in the future, maybe 1 year from now, 2 years from now, or 5 years from now. But as of now, you are going to make the design. And design includes budgeting. So in budgeting, you need to estimate what will be the prices, what will be the interest rate in the future. Okay, so that is the introduction for our course. Okay, and okay, so we discussed this one already in the first chapter. Yes, Mazin. That's right. That's correct. Okay, and we say that okay, what we are aiming for engineering economics is to ensure the best use of capital. That's why we need to evaluate any engineering project. We cannot afford to lose our resources. We cannot afford to lose the resources of the company. That's why that is economic essence of the engineering projects. And I think most of you are already taking the senior project. I was hoping that if you are going to take this subject in senior project, you can integrate engineering economics in your projects, because sometimes we need also to think about the resources that we are going to use with our project. Well, some they just think of any project for submission so that they can pass the subject. But what is important there later on, okay, whether it is your project in your subject or maybe your project in the companies later on, is that we can see the best benefit of the resources that we are going to use with these projects. Okay, so that is the essence of engineering economics. That's why we have this part. We call this as economic evaluation. Okay, so we have steps in economic evaluation process. We discussed this also during the introduction, but just to give you a review so that we can link those topics in introduction to these topics. Maybe you are wondering before why we were discussing about the decision making and many other things. So we can also apply it here. When we are going to evaluate engineering projects, we need to undergo several steps or process called as economic evaluation process. And of course, this is patterned with what we call as rational decision making. And we discussed already why rational. This is the best decision-making method because here we are dealing with a lot of money, huge amount of money. That's why we cannot just afford We cannot just afford to make a decision that will enable our projects unsuccessful. Meaning, if our projects are unsuccessful, what will happen to the resources that we use for those projects? It will be wasted. Okay, so we need to use the best type of decision making here. In making, actually, in implementing a project, it is always that there is a decision making first, because we involve huge amount of money here. Okay, so we see that the first step is to identify and understand the problem and identify the objectives of the project. Secondly, we collect relevant information, available data, and define the viable solution alternatives. And third step is to make realistic cash flow estimates. And fourth is to identify an economic measure of worth criterion for decision making. And fifth is evaluate its alternative, consider also the non-economic factors, and then after we evaluate the alternatives, now it is the time for us to select the best alternative from the evaluation that we conducted. And then seven, of course, is implementation of the solution. Well, in engineering economics, we go farther, but of course, in our course, we are only up to selecting the best alternative. That is step number 6. So step number 7 is in actual. You can do this, implementing, and actually number 8 is monitoring. There is monitoring here. Okay, so let's see how we can do. Okay, in page 195 to 196 of your book, if you have your book now, so I copy this part of that book. So this is our working problem. Do you have your book now? So please go to page 195 to 196. You can see this problem here. Okay, have you checked your book? Page 195 to 196. Okay, there's a problem there. If you can see that one already in the book, it says, actually this is a problem relating to mechanical engineering. So if only we have sufficient time, we will have not only for mechanical engineering, but also chemical engineering as well as electrical engineering. But of course, this is the one in the book. So those who are not from the mechanical engineering, so sorry for now. Our focus is on the mechanical engineering. But of course, most of the projects involve all the other related fields of engineering. So don't worry, we involve that one later on. So what is this problem all about? It says here, it is a machine shop that considering combining machining, turning centers into a single Mazak multitasking machine. So this is the title of the project. Okay, it is a Mazak multitasking machine. So already when we say multitasking, multitask, many tasks. That is combining the different functions of the machine like turning, machining, and so on and so forth. Okay, so multitasking in the machine world is the combination of the different processes that were traditionally processed on multiple machines into one machine. So you know already that different functions require different machines. But in this project, they are trying to combine all the functions into one machine. So that's why it is called as multitasking machine. Now, the ultimate goal is to turn, mill, drill, top, bore, and finish the part in a single setup. So that is the main function of the multitasking machine. And take note, the total investment cost is 1.8 million. That is the cost of the machine. And we have the anticipated cost savings. When you say anticipated, this is the estimated cost, reduction in cost. Expected, yes. So anticipated or expected or estimated savings. Okay, like for example, for setup, how many percent can we save with that machine? It is 70%. So that is 70% of $335,000. Okay, that is equivalent to 234,500. So that is the total savings. And then we have, for example, operators, 220,000. So we can save 100% of that amount. Okay, so we have scrap, rework, operators, fixturing, and so on and so forth. That's why the total savings is $908,000. Okay, so remember that. Now, step number 1, we said that we need to identify and understand the problem, identify the objectives of the project. Okay, now, can you still remember the types of strategic engineering economic decisions in chapter 1, introduction and chapter 1? So, analyzing that problem, what is the type of strategic engineering economic decisions is involved in that problem? That is now identifying and understanding the problem. Okay, remember before they have separate machines to do different different functions. But what they are going to do is to come up with a machine that will do all the setups so that they can reduce, so that they can save. Okay, saving means we are also reducing the cost. So therefore, Hassan is correct when he said cost reduction. Okay, so the first thing that you are going to do is to identify what type of problem you are addressing. So this time it is cost reduction in this example. Okay. Now, aside from identifying the types of strategic economic decisions, we need also to distinguish whether this project is about project acceptability or it is about project selection. What's the difference? So when we say project acceptability, we involve only one project. That's why it's either we are going to accept or we are going to reject. While project selection, from the word selection, there are alternatives that we are going to select one or two from these alternatives. So project acceptability involves only one project, while project selection involves more than one projects. That's why it is called as project selection. So engineering economics actually is more on project selection. Why? Why engineering economics is more on project selection? Because this is economics. And we said in the guidelines that we need to develop alternatives. So we are not only to do the analysis, yes, but both project acceptability and project selection have analysis. But why project selection? Because one of our guidelines says that we need to develop alternatives, because maybe from among the alternatives, there is a better alternative than the one that we are presently proposing. That's why we are not more on project acceptability. But of course, the basis of our discussion is project acceptability, and then we are going to apply that to project selection later on. But take note, we supposed to focus on project selection because that is economic thing. Okay, and then another variable, okay, or determinant that you are going to understand is the MARR. So the MARR means minimum attractive rate of return, or in other business subjects, it is called as hurdle rate. And this is the minimum rate that the company or manager expects to earn when investing in a project. Okay, so what do we expect from the project? How much we expect? That is expectation rate. And usually, okay, so this is one example of ARR. Suppose the market rate is 10%. The market rate is 10%. Return means what? Okay, return means in general, that is the profit, the benefit that you can get from the project. Return. So you need to invest. In the return, what do you expect? Okay, so is it clear what return means? So starting from now, so whenever you hear the word return, it means benefit that you can get from your investment. Okay, now suppose the market rate is 10%. Okay, and you have money and you invested it in maybe in any investment. But of course, if we are going to invest, we have already a clear idea what will happen to our investment. Not exactly, but at least we have. That's why we have this engineering economics, because here we learn how to analyze the investment so that we can see, we can have an idea whether this investment is worthy or not. Now, suppose after the analysis, okay, you came up only that the return will have like 5%. So, are you attracted to invest in that kind of investment that after the analysis, what you got is only 5% return? So, no. No, it is not. It is not about. It is not about predicting the worst here, but MARR is the benchmark. Okay, just like what I'm saying. Okay, suppose. Okay, you are planning to invest your money. So after the analysis, you realize that the return of your investment will only have 5% return per year. But the market rate, like for example, bank is offering 10% of your investment yearly. So are you attracted to invest in that kind of investment? You know that the return, you realize that the return. Okay, yes, Ali, it does not worth, right? 5% only. So if that is the case, better put your money in the bank, because in the bank, it is safer, less risk, and it will have 10% rather than risking your investment, and later on you will just have 5% return. So therefore, yeah, about the worth, that is about worth analysis. So the worth of your investment is only 5%, for example. So are you attracted to invest in that kind of investment when you know that there are some, like for example, the bank can offer you 10% higher than the worth analysis that you have computed on the investment that you're planning? So you are not attracted. So what is the minimum rate that will attract you to put your money in that investment? It is 10, right? It is 10%. That is the minimum. Well, the higher, the better. But at least 10%. Because below 10%, you will not be attracted to invest. Is it clear? So the minimum rate to attract you to invest is 10%. Because lower than 10%, maybe you will not be attracted to invest. That's why it is called as minimum attractive rate of return. So in this case, the investor or the manager is going to put his expectation, what rate he is attracted, so that he is attracted to invest. That is now what we call as MARR. So since the market interest rate is 10%, usually we put MARR equals interest rate. So if we are going to compute the time value of money, why 10? Suppose you realize it is 9%. The return of your investment is 9%. But there is, for example, the bank, the market interest rate is 10%. Are you attracted to put your money in 9% only? Are you attracted to put your money there? No. That's why we are saying it is the minimum 10%. Otherwise, if it is lower than 10%, then I will just put my money in the bank. It will earn 10% rather than put it in the investment. I will realize only less than 10%. So if the investment is 10%, that is the minimum. Below that 10%, I'm not going to invest in that type of investment because that is lower than the market interest rate. That's why here, when we say MARR, it is the interest rate that will attract us to invest. That is the minimum interest rate. That means lower than that, we are not attracted to invest. So that is what we call as MARR. That's why whenever you see MARR later on in the problems, that means that is the interest rate that you are going to use. So when it say MARR equals 20%, so when you compute for the time value of money, the small letter I there is that MARR. So if MARR is 20%, your I, small letter I, is also 20%. Okay, so that is the MARR. Okay, let's go to step number 2, collect relevant available data and define viable solution alternatives. Okay, so what we can collect there, we have available data. It says initial cost or investment cost is 1.8 million and annual savings is 908,000. Okay, so we got that from the problem a while ago. So that is what you're going to do also. You need to gather information. Number 3 step is to make realistic cash flow estimates. Okay, we have the data already. Okay, we have initial cost or investment cost, 1.8 million and annual savings. Okay, so you need that to come up with estimated, we call this as realistic cash flow estimates. Okay, so another additional information that we gather also in that problem, it says most machine shops typically use 7 years. Okay, so that is n equals 7 already, and assume 20% residual value. Okay, what is residual value? From the word residue. What is a residue? Okay, I think those chemical engineering students, they know, they always talk about residue in their experiments. So what is a residue? Something that remains after the process. So we call that as residue. In engineering economics, residual value, that means to say, suppose the life of the machine is 7 years. Okay, and we expect that at the end of its life, at the 7th year, after 7th year, the value of the machine becomes 0. But usually there are some machines that after its life, still you can use it. You can use them. It can still generate. It can still generate revenue or income. Or aside from using it, sometimes we can sell after its life. For example, 7 years. After 7 years, we can sell that machine as second-hand, and we can get sales from selling that machine. The amount of what we are talking about, the sales or the additional revenue that the machine is still generating, we call that as a residual value. Okay, so we assume that the machine has a residual value of 20% of its worth. What is the worth of the machine? What is the cost of the machine? It is 1.8 million. So we assume that after 7 years, we can still get 20% of 1.8 million as its residual value. Is it clear what is residual value? Okay, so it is also common for learning curve to take place operating a complex new machine. I don't know if you discuss this in your engineering subjects, that sometimes if we have a new machine, there is what we call as learning curve. That means to say learning or training curve. That means to say the full benefit of that particular investment cannot be achieved 100% yet for some time, because there is a learning curve, training curve. Like for example, in this multitasking machine. So once you implement this machine, you cannot say that you can eliminate all the operators already. Still, we need them. And we can eliminate those operators slowly until we can manage this type of machine. So we call that as learning curve. That's why we need also to assume, it says here that only 50% of the full potential savings of 908,000 occur during the first year and 75% during the second year. That means to say for the first 2 years, we cannot get yet the full benefit of the machine. So only 50% in the first year and 75% in the second year. So those are the considerations. Now, let's make the cash flow table. So the first the first column is our N. Okay, we have 7 years, therefore we have 0, 1, 2, 3, 4, 5, 6, 7. And the first one is cash in. And then we have the cash out. And then we have the net cash flow. Okay, what is cash in? So we discussed this one earlier in the time value of money. So anything that will come in to our pocket is called as cash in, and cash out is anything that we get from our pocket and pay. So what are the cash ins? Okay, in this type, because the problem is about cost reduction, so it is savings. So savings is considered as cash in, because supposed to be we are going to pay that, but because of the cost reduction, we keep that as savings. So it is considered as cash in. Okay, so we'll put I think only savings and the other one. How about the residual value? How do you consider residual value? This is the sales, the amount of sales if you are going to sell the machine after its life, 7 years. Okay, so it is cash in. So we do not have other things like income or withdrawal. We do not have like that. So those are examples of cash in. Later on, you will encounter. Okay, now, since the residual value is computed at the end of the life of the machine, so it is always at the end of the life of the machine. Okay, so let's compute. Okay, 50% of 908. 908,000, 50% is 400. Okay, so we do not have year 0. So we start with year 1. Okay, we have 454,000. Okay, and then year 2, we will get only 75% of 908,000. 75% of it is 681,000. And after that one, year 3, we can get the full potential already of the savings. So we have 908. Okay, 908. Okay, but since we have residual value at year 7 or at the end of the life of the machine, so we need to add the 20% of 1.8 million. So how much is 1.8 million? So we have 306 plus 360,000. Okay, so that is our cash in. Then we need to specify our cash out. So in this example, we only see one cash out, which is the investment cost. And usually the investment cost or initial cost, that's why it is called as initial cost, because usually we see this cost at the start of the project, which is in year 0. So that's why we have 1. Okay, that is 1.8 million. Others, there's no cost that is specified already. Those are the only thing that is given. Okay, so we do not have other costs here. But just in case we have other costs, then we need to put it. But since we cannot see in the problem other costs, yeah, operating costs like that. Okay, probably because this is cost reduction, the savings is already the net of the benefit and the savings. So the savings 108,000 is already the net. The operation costs costs are already taken from that value. So for the meantime, these are the only thing that we can use. Anything that is not in the problem, 360,000. That is cash in, Hassan. We need to add that one in the cash in at year 7. That is 20. Yes, Masin, that is 20% of 1,800. 1,800,000. Okay, so after we compute the cash out, then we need to compute for the net cash flow. The net cash flow is cash in minus cash out. That's why this is 1. Okay, and then we have 454,681. Okay, 908. And this one is, I think it is totaled by, okay, Mazin total is 1, 2, 6, 8. Okay, so this is now step number 3. So make realistic cash flow estimates. So indicate all the assumptions so that you will include that in the preparation of the cash flow table. Now, the most important part here is this part. That's why don't make any, okay, don't be wrong in your assumptions in the cash in and the cash outs, because it will affect the net cash flow. Realistic meaning more or less it is real, actual, closest. Remember, these are estimates, but when we make estimates, we need to make it more or less closer to the reality. Don't put anything. That's why be realistic. So when it say cash in, The savings is 900. That's why in year 1 we did not put 908,000 immediately, because we know that we cannot achieve that. We cannot achieve that during the first year. Or in the second year, we did not put immediately 908,000 because we know that we cannot achieve that. So we need to make some realistic estimates. Yes. Why realistic? Of course, the closer to reality, the better when it comes to estimates.
Excuse me, teacher.
Yes, Mazin.
What I meant is, how did you consider 50% in the first year is realistic, and in the
Well,
third year, 100?
yeah, that is okay. You need to decide on that one. Of course, what are the factors that you can do that you are going to include? Like for example, okay, remember the table about the savings? The table that we have a while ago.
Yes,
Okay.
yes.
Okay. Now, for example, you think that on the first year we cannot remove all the operators yet. How many will be? How many will remain? So you can estimate for operators. You cannot get 100%. How many operators do you need during the first year? So therefore, you can estimate the salary. How much savings on the operators? Maybe no savings yet. So get the total here. And later on, you can say, okay, maybe we will assume that we can get only 50%, right? Okay, so what are the things that you cannot yet get 100% from here? Okay, that's why we have estimates. Like for example, set up 70%. So maybe since we do not know exactly, we are not yet familiar with the machine, maybe for the setup, we cannot save 70% yet. Maybe only 20%. So that is how to estimate. That's why for your projects later on, you need to make estimates. Okay, so that is how to make realistic cash flow estimates. And as I said, this portion is very important to be accurate, because if it is not that accurate, your estimation your analysis later on uh, will not be accurate also. So you need to specify exactly what are the cash ins and what are the cash outs, so you can get a good net cash flow. Okay, so here's the table now. Okay, so this is the most important part, the net cash flow. Okay, number 4. Okay, identify an economic measure of worth criterion for decision making. So how are we going to decide later on whether we accept the project or reject the project, or which project we are going to select? So we should indicate our criteria. And these are our economic measure, or we call this as our criteria. Okay, we have 10 actually. And these are the economic measure, and here's the criteria. So take note that we discussed earlier project acceptability and project selection. So for project acceptability, for example, okay, we have the acceptability, we involve only one project, while selection, we involve more than one projects here. So we are selecting, while acceptability, we are rejecting or we are accepting. So these are the measure that you need to to remember when you are going to decide. Okay, now why we have a lot of economic measures? Why not only one? Why not only two? Okay, one reason is that one economic measure cannot give you the total picture of the economic analysis. Like for example, discounted payback period is going to tell you only when are you going to get back your investment. So it is the time that you will get back your investment. So in this case, when are you going to get back your 1.8 million? That is the payback period. But it will not tell you the profitability. So you need to use profitability such as present worth, future worth, annual equivalence, rate of return, and so on and so forth. Okay, so each one of these measure has their own uses. And not one of this economic measure can give you a total picture of what you are looking for. That's why we need to use different economic measures. So for acceptability for discounted payback period, okay, it is blank. Okay, why? It depends on the management. It depends on the evaluator. Okay, but if possible, the payback period should not be more than half of the life of the project. So that is one of our considerations. But it depends. Sometimes, even though the payback period is quite long, but the profitability is very high, then you need to trade off. Remember the trade-off in the introduction. Usually, we make trade-off. Like we accept the project, even though the payback period is life of the project is not exactly. Depreciation is another measure. It is not the life of the project. The life of the project is the how many, but depreciation is affected by the life of the project. Okay, because depreciation is a cost that you deduct from the income of the project, so that when the project ends, like for example here, 7 years, so that after 7 years you have some amount to replace the equipment. No, it is not the value of the equipment after a specific years. Usually the value of the equipment supposed to be is zero at the end of its life. That's why you need to buy again. And where to get the amount that you're going to buy? It is the amount that you are deducting from the income. We call that as depreciation cost. So that at the end of its life, you have something, you have an amount. Yeah, that is distributed. How much you are going to get each year. Okay? To be saved, so that at the end of its life, you have a replacement. You can buy a replacement. Okay, so this is what we are going to use. So have a note on this. Selection is quite different from acceptability, because for discounted payback period, okay, usually it's good that all of you are gentlemen, because ladies do not agree with me sometimes when I say the shortest is the better. Okay? What is what did Eid said? Okay, others maybe they are sleepy. That's why they were not able to get what I said. Okay, I said for payback period, the shortest is the better when we are selecting the project. But of course, okay, yeah, yeah, now I know. Okay, so well, discounted payback period, the shortest, the better. Okay, others, the highest, the greater, the better. Except for annual cost analysis, again, lowest. Break-even analysis is lowest, and risk analysis is lowest. Any questions so far when it comes to this criteria for the economic measures, this is the basis for your decisions later on. So, for example, the discounted payback period that we are going to compute in this example, multitasking Mazak multitasking machine. For example, the payback period is 4. Well, it says here blank. So it depends on the evaluator, or it depends on the management of the company. But 4 is quite long already. Can you imagine? The life of the machine is 7 and the payback period is 4. That means to say it is only after 4 years that you will get back your investment of 1.8 million. Okay, so we'll go back to this one as our reference later on. So make this as your reference whenever you make analysis. And then we have number 5, evaluate its alternative for the project selection. Okay, and consider non-economic factors such as the risk. Okay, risk is not economic factor, so therefore we need also to include that. Remember, in the guidelines, it says there, can you still remember that one? We need to include all the relevant criteria, but we need also to include uncertainty, which is non-economic in here. Okay, so now, after that, number 5, so after that is to select. Now, in selecting, usually there is a trade-off. For example, in project selection, you have 3 alternatives. Okay, maybe one criteria, it is A. Okay, second criteria, maybe it is B. Maybe third criteria is A. Maybe fourth criteria is C. Okay, now you need to study which one you are going to give up, what criteria. But of course, you need to go back again to the fundamental concepts of engineering economics that says profitability is the most important thing there, especially when compared to risk. Sometimes we can tolerate the risk as long as the return is very high. Can you still remember that fundamental principle in engineering economics that says additional risk is not taken if there's no higher additional benefit or additional return? Well, you need to remember those principles because that will help you to justify your decisions later on. Okay, now let's move on. Any other any question before we proceed? Okay, so the first measure that we are going to do is the discounted payback period. Actually, there are 2 types of payback period. One is the we call this as the traditional payback period, and the other one is discounted payback period. Well, what's the difference? The traditional payback period doesn't consider the time value of money. That's why it is not being used anymore. Although the process is almost the same, the only difference is that discounted payback period considers the time value of money. Okay, that's why I'm not going to discuss anymore the traditional payback period. Let's go directly to discounted payback period because this is the one that is being used in most project analysis. Actually, they are not anymore using the traditional one. Okay, what is discounted payback period? So it says here, the payback, so that you can see the page number. If you want to refer to your book, you can find it here. So I put the page numbers. So the discounted payback period or the payback period method screens projects on the basis of how long it takes for the net receipts to equal investment outlays. So how long it takes for the net receipts, what you receive, to equal the investment outlay. In our case, we invested 1.8 million. So when will be the time that the investment cost or the amount of investment equals the net receipts from the word receipt, what you receive? Or in other words, when are we going to get our investment? So payback period is the length of time. So it is measured by period, time, duration of time, usually years. Okay, length of time required for an investment to recover its initial outlay, which is the amount of investment in terms of profits or savings. Okay, so it is the one that we're going to compute is the time. Now, the first is we need to consider the net cash flow. That's why you see here, the net cash flow is very important because that is the basis for our computation. Okay, so what we are going to do here is to compute the cumulative cash flow. What is the cumulative cash flow? From the word cumulative. So we accumulate the cash flows. Okay, how to do that? So first, in year 0, we'll just copy the net cash flow. So that is negative 1,800,000. Okay, so that is the first, the initial. And then for year number 1, okay, take note that year number 1 year has passed. So in other words, we need to charge the amount, the initial amount with the MARR or the interest. So in this case, actually our MARR is 15%. Okay, that is according to the book, to the problem. Okay, so to compute for year 1, we have negative 1,800,000 multiplied by 1.15 plus, okay, this amount, 454. Okay, that is how to compute there. Okay. Yes, but what is specifically in year 3, Abdullah? So we need to be specific here because 1 year is, okay, so is it negative? It is negative, right? So negative 1,616. Okay, so there is a point there. So for the next year, what you will do is, again, that is 1,616 multiplied by 1.15 plus 681,000. So that is how you compute. I think there is okay. I think there is a problem in your calculator, Hassan. Okay, so 1, is it 1, 1, 7, 8, 400. Okay, so that is the process. Is it clear how we do the cumulative cash flow? Okay, so that is the okay, for all the years, so we have that. Okay, now The discounted payback period actually is when because this cumulative cash flow is also considered as project balance. So don't forget, this is also called as project balance. Okay, now if the balance is still negative, that means to say we did not recover yet our investment. That's why our balance is negative. But if our balance is already positive, that means we have recovered already our investment. Okay, so where is the payback period? Okay, the payback period is the turning point. Okay, in concept, the payback period is the turning point. That means to say that is the boundary between the negative balance and the positive balance. So in other words, where we can see the payback period. Okay, we have here negative and this is positive. So in other words, somewhere here, there is a payback period. There is a cumulative cash flow that is equal to 0. Okay, one description of payback period is that it is the cumulative cash flow equals 0. So it is here, somewhere here. So that if the balance becomes 0, that means to say we paid off all our negative balances already and we are gearing towards the positive balance. So we can use the ratio and proportion and interpolation to get the exact. Okay, so how did we get 3.4 there? Okay, so we have here, okay, we have 3, year 3, and we have negative 446,010. Okay, somewhere between 3 and 4. Okay, for year 4, we have 395,088.5. Okay, somewhere between 3 and 4, year 3 and 4, there is 0 here. But we do not know what is that here. That's why we just put n. Okay, by ratio and proportion, so we say that the distance between 3 and, okay, 3 and n is x. So we get also the difference between this part, and this is 0 minus negative 1446010. That will become positive 446,010. Okay, let's get the distance between 3 and 4, which is 1. And let's get also the distance between this value and the value of 4. So that is, okay, 395,088.5 minus 446,010. So we have 395,088.5 okay, so we have 841,098.5. Okay, so ratio and proportion, we have x over 1 equals 446,010. So we have 841,098.50 equals, so 446,010 divided by 841,098 0.5 is 0.53. So in other words, the x there, the distance between 3 and n is 0.5. That is 0.53 or just 0.5. So if you are going to add that to 3, that n is 3.5. So our payback period is 3.5. Okay? Okay, so that is how we get the payback period. Okay, so save the value. Payback period is 3.5 because we will use that later on to make decision. But for the meantime, we need to get other information. We need to analyze using other economic measure. Any question on the payback period? Okay. Next, we have in page 200, we have the present worth analysis. So what is present worth analysis? Okay, present worth analysis is also called as the NPV or net present value. Okay, this is the difference between the present value of cash inflow. So take note, difference between the present value of cash inflow and the present value of the cash outflow over a period of time. Okay, usually we use the PW in capital budgeting and investment planning to analyze the profitability of the projected investment or project. So take note, this is one of the profitability measure. Well, as I said a while ago, payback period cannot give us profitability. And another disadvantage or pitfalls of payback period is that, okay, suppose there is another negative balance here. So you see, this is the last negative balance, and suppose there is another one here. Then you cannot anymore compute for the payback. There is no, we call this as undefined payback period. So we cannot define the payback period once there is another negative after the positive. So that is one of the pitfalls of payback period. Second, as we said a while ago, the payback period cannot give us the profitability picture of the investment. It will only tell us when we are going to get back our investment, but it will not tell us the profitability. Because maybe here, these are positive balances here, but maybe they are very small already. Still, they are positive, but they are not profitable anymore. Okay, so now we have the present worth analysis that measures the profitability of a project. Okay, I will give you one example. Suppose, okay, you have $100. You want to invest, you invested your $100. The MARR or the interest rate at present, okay, is say it is 10%. So after 5 years, what is the expected future value of 100? What is the future value of your investment? Is it 161.05 Mazin? Okay, so Mazin computed it in 5 years. So we have 161. This is the expected future value. Okay, but what happened? What really happened? So this is only estimated during the start of the project. But during the course of the project already, maybe the manager is very diligent, and he is very good in managing his business. So instead of 161.05, at the end of the fifth year, his future worth is not 161.05, but instead what he got is, okay, 250, okay, say 250 flat. Now, what is the present value of 250? What is the actual? Remember, we have the actual dollars, we have the constant dollars. Here, we are computing the actual P of 250. What is the P of 250? So compute for the P of 250. What is the actual P? Okay, it is 88. Are you sure it is 88? Okay, so 155.23. So in other words, how much you invested, actual investment? It is only 100, right? But the worth of that is 155.23. So if we are going to subtract 100 from 155.53, we have 55.23. So how do you call this 55.23? This is now what we call as present worth. Okay, actually it is just like the worth of a good is 155.23, but you paid only 100. You got my point? What is present worth? Okay, you invested 100 during year 0. After 5 years, you expect that it is 161.05, but instead of that, okay, you got 250 instead of 161. And the worth of 250, the P of 150 is 155.23. So what do you mean by doesn't make sense, Mazin? Any comment, Mazin? Yeah, you see, you have, it is just like a profit at the beginning, right? The worth of your investment is 55.23 more. Remember, you are only investing 100. That is almost half of your investment. Who doesn't like? Well, that is the actual result of your business, because maybe you are very good in managing your business, your investment. So at the end of 5 years, you got 250 instead of 161.05. Yeah, you got what I mean? This is the expected F, but what is the actual F is 250. Because maybe the investment is very good, the project is very good, it brings more income. So at the end of 5 years, you got 250 instead of 161.05. Now, look at the P of this 250. It is 155.23. That means to say, the worth of your 100 is not 100. It is 155.23. That means to say, suppose you bought a ball pen. Okay? The worth of the ball pen is 10 reals, but you paid only 5 reals. Doesn't worth it? What does it mean for you? If the worth of the things that you bought is 10 reals, but you bought it at 5 reals only. Is that good or not good for you? Yes. So your PW is 5. That is good. That's why your PW must be greater than 0. Okay? If it is lower than 0, that means to say you paid more. Like for example, suppose the actual P of this investment is 88. So that is 88 minus 100, that is negative, that is lower than 0. Well, that's why we have time value of money, Ali, because we considered inflation rate already. We have, how did you compute 161.05? Did we not use the interest rate here? Did we not do the time value of money here? So that's why inflation rate is already included in the computation. So you see here the projected investment. The difference between the present value of cash inflows and the present value of cash outflow. So this is now the difference between the present value of cash inflows and the present value of cash outflows. That is the PW. So if it is greater than 0, then that is good. But if it is less than 0, that is not good. That's why if you look at there, so even in acceptability, the PW must be greater than 0. If it is less than 0, then do not accept the project for present worth analysis. But take note for selection, regardless if it is 0 or negative, okay, number or positive number, what we are going to select is the project with the highest PW, regardless if it is negative or positive. Okay, any question on PW? Okay. So the present worth of this example, okay, so we have computed how to compute. So we need to compute the different PW of each year. Like for example here, how to compute the PW of that one. So we have negative 1,800,000 multiplied by 1.15 raised to 0. How about this? This is, okay, 454 multiplied by 1.15 minus 1. This one is 681,000 multiplied by 1.15 minus 2. And then come up with, okay, sum up all. You have, okay, 1,546,571.23 Okay, what can you say about the PW of this example? Okay, how much is the investment? Our investment is only 1.8, but actually the worth of that investment is 1.8 plus 1.5. 1.5. So total 1.8, 1.5, 3.3. So that means to say, when it comes to profitability, your investment of 1.8 actually is worth 3.3. So you see, you paid only 1.8, but actually what you bought is 3.3 million. That is the meaning of the PW here. Okay, do you have any question on how to compute for the PW? How to compute for this one? By the way, for equal, we have like equal payments. So you can do the shortcut. Remember how to compute for the P of A. You know the formula to compute? So you can compute like that. It is a shortcut. But here, we do not have equal values here. They are not equal payments. The fact that we have different values here, then you do the long method, an even formula. So you need to compute the P of every net cash flow. Yeah, you can use the equivalent payment formulas if the value are equal. How to get PW for this example? Okay, compute for the PW. Compute for the P. Okay, so you are bringing all this value to year 0. So here, okay, that one is negative 1,800,000 multiplied by 1.15 raised to 0. This one, this is 454,000 multiplied by 1.15 raised to negative 1. Negative 1. Going there is negative 1. Negative 1, 2. You know, don't forget how to compute for the P of these values. You can make the, the cash flow diagram. Okay, 0, 1, 2, 3, 4, 5, 6, 7. So here we have negative. So year 1, okay, that is going down. That is negative 1, 8, something like that. So going there. Okay, so that is how to compute for the PW. Okay, look at the criteria. So PW must be greater than 0. Now it is greater than 0. So that means to say the profitability of this project is good. Okay, other question? Okay, last for this time. Same as the present worth analysis, we have the future worth analysis, but this time we will use the F, the future value, instead of present worth. Same procedure. Okay. We do this, but this time it is FW. So therefore, here we have negative 1 multiplied by 1.15 raised to what? Yes, correct. It is 7. Because we are going here to year 7, future value. And this one is 454, 1.15 raised to 6. This one is 681, 1.15, 5. And then 908, 1.15, 4, and so on and so forth. So you can compute that. So once you compute, okay, so this is now the FW, and this is now the total. Okay, that is 4113910.22. Now, what is the meaning of the future worth analysis? So here we are in present worth analysis, we look at the profitability of the project based on the P. Here, we are looking at the profitability of the project based on F. Now, it says here, future worth is the value of the current asset at a future date based on an assumed rate of growth. Okay, and what is the importance? It says, it is important to investors and financial planners as they use to estimate how much an investment made today will be worth in the future. So it says how much an investment made today will be worth in the future. That means to say the investment of 1.8 million at year 0 will be worth 4,113,000, okay, 1,910 in year 7 at the end of the life of the project. So this is the worth, the future worth of your 1.8. Yes.
As that means if we don't invest 1.8 million in this year, after 7 years, we need 4.1 million for the
No,
same
it is not
investment.
like that. No, it is not like that. So, what is the future worth of your 1.8? So that is what it means. You invest 1.8 now. After 7 years, what will be the worth of your investment? The worth is 4,113,910.22. That is the worth of your 1.8 now at the end of year 7.
Yeah, what do you mean by worth in this case?
Worth. So how much? Okay, you have 100 now. After 5 years, how much your 100 is worth? Does it increase its value? Has it increased the value?
It should be.
It should be, because if it is not, then you lose. Like for example, you invest your 100 now, and then maybe because you are a good businessman, after 5 years, your 100 became 500. So what is the worth of your 100 now after 5 years? It is 500. Right? Well, another thing about W is that look at the number, look at the FW that we have, and look at the okay. Did you observe something?
Is it the same?
Yes. That means to say the future worth of your investment is the balance of the project at the end of its life. How much you have at the end of the life of the project. Remember, cumulative cash flow is the balance of the project. That means to say, what you will have, how much you will have at the end of the life of the project is the future worth of your investment. You got it?
Yes, it's clear now. Thank you so much.
What is your balance at the end of the life of the project? What is your balance? What is the amount remaining to you? Okay, like for example, today is the end of the life of the project. How much you have? 4 million. That is the worth. That is the future worth of your 1.8 million. At the end of 7 years, you will have 4 million. Okay, so it is greater than, okay, lastly, for our analysis here. Okay, that is only what you have during at the end of the life of the project. Okay, but suppose you invested your money in the bank, how much you will have? Well, it is good that it is positive. But another way to analyze that one is, suppose you invested your money in the bank and the bank offers also the same 15% because that is the MARR. That means to say the F of your money is 1.15 raised to 7. Okay, how much is that? That is the expected F, or expected future value, if you invest that in another investment. Can you compute, please, so that we can, okay, what in 1 minute? I hear some, okay, the wife is already calling. He said, time, it's time already. Okay, you see, it is 4.7 million. If that is correct, Abdurrahman. Okay, 035. Anyway, I trust Abdurrahman in his computation. I think he has I think he computed it in his computer or just calculator. Okay, you see, compare the actual F or the FW with the expected F. That means to say, if I put my money 1.8 million in the bank, it is higher after 7 years compared to the actual F of my money. Okay? You see how we analyze. Usually, okay, it is acceptable if the FW is greater than F. But this time, the F is greater than FW. In terms of the balance of the project, it may not be good. Well, you can justify later on. That's why we need other measures so that the other measures maybe can compensate the failure of the other measures. Well, you need to have a trade-off later on. Which one is more important? Or can you accept the project even though the F is greater than the FW? So you need to decide on that one. But still, this one is also good. It is positive, only that it is lower than the expected F. But there are tools that cannot be used with project acceptability, but they are essential and they are very useful in project selection later on. Okay, so we finished already present worth analysis, payback period, and future worth analysis. And in relation to the future worth analysis, because we say that the we define the future worth as the value at a future date, or that is the balance. So the future worth of the project is the balance of the project at the end of its life. Okay, and if we I told you a while ago, if you have observed that the future worth is the last balance or the last line in the cumulative cash flow. And remember that the cumulative cash flow is the balance of the project. So if you are going to graph it, if you are going to show it in terms of the exposure to financial risk. Okay, so I relate this one to future worth, to the cumulative balance of the project. Actually, there are many measures of the risk. Remember that one of the guidelines says that we need to include also explicit things. Okay, something and other things that cannot be measured. For example, risk. So risk is not quantitative data. It is not quantified. It is not a value, but the level. Okay, but later on, it says we need to make a way that we can also include the risk in our analysis. So risk is very important in our analysis. In your engineering subjects, maybe you were talking about risk. There are many measures, but this time, okay, you can see the page there. Can you see the page in the slide, page 210? Okay, so can you see this? That is the page number. Okay, so there are a lot of measures of risk, but this time, because of the limited time that we have, we can only discuss one type of risk, and this is the exposure to financial risk. So in other words, we are going to look at the balance of the project for the financial risk. Okay, so Here we have the cumulative cash flow, and we said that the cumulative cash flow is also the balance of the project. And you can notice that you see from year 0 up to year 3, the balance of the project is negative. What does it mean by negative balance? So it says here, a negative project balance indicates the amount of investment to be recovered. So that means to say, you have not yet recovered your investment. That's why this is also related to the payback period, because the payback period indicates that the time you recover back your investment. So while it is not yet a payback period, that means to say the balance of the project is negative. And why it is risky if the balance of the project is negative. So it says here, negative balance is exposed to risk of loss. Suppose the project, our example, is stopped during year 2. So here, if something happened to the project at year 2, remember that this is futuristic. That means to say it is not yet happening, but it might happen. That's why if there is something happen to the project at year 2 and the balance is still negative, that means to say we have not yet recovered our investment, but instead we are going to pay such amount if something happened to the project and it stopped. So that is the risk. While the balance is still negative, there is risk. Okay, that is a financial risk. So it says here, if the project is terminated at this point, at the negative balance, so the negative project balance area will increase if the cash received from the project is less than the interest owed to the period. Okay, so now how are we going to assess the risk based on the project balance? So what is this risk analysis that we are considering here? This is the risk based on the project balance. So if the project balance is still negative, the project is still at risk because we have not yet recovered the investment. We are still paying. We are not yet receiving income or return or benefits. Okay, so now we need to make some measure how to assess the risk. In this class, although I cannot find what they call a standard way of assessing the financial risk, but here we can get it from the ratio of the what we call this ratio of the negative balance to the total life of the project. Like for example, here usually to get the ratio, we have the PBP, compute first the PBP or the payback period divided by the number of years as the life of the project. Okay, so here we have, can you still remember, have you recorded the payback period that we computed last week? So it is 3.5 years divided by 7 years. Okay, so this is 50%. Right? So it is 50%. That means to say 50% of the total life of the project is at risk. Okay, now for the decision here, it depends. For project acceptability, it depends on the management, whether the management can accept 50% risky life of the project. But of course, for project selection, the lower the risk, the better. That's why we select the project with the least risk. So some interpretation here. Okay, and we said a while ago that if possible, the payback period should be not more when it comes to the analysis of the risk. So at what point risk is acceptable? But it says here, it depends on the prerogative or to the decision of the management. And in our engineering economics principle, we said that we can take the risk as long as the return is high. So what is important here is the return or the benefit that we can get from the project. So sometimes we ignore the risk as long as the return is high. Of course, they say you cannot be a businessman if you cannot take the risk. So here, how we are going to assess just for our analysis. So I recommend the following. So 0 is no risk. That is 0%. Of course, 0% is no risk, but you can seldom see a project with no risk at all. So from 1 up to, okay, let's say this is 1% to 10%. This is low risk. And if we have 11 up to 20, that is medium. Okay, 21 to, we can see here, this is already considered as high risk, and above 30, very high. Okay, so please copy. This is just for our analysis, so that we can present we can include the risk in our analysis later on. So we will use this as our standard for our class only. Okay, so that when you compare the different projects later on in terms of risk, so we use this as the description of the ratio of the risk from the life of the project. Okay, so do you have any question with regards to risk analysis? Okay, let's move on. Okay, so another one tool that we can use is the annual equivalent worth criterion. Actually, this is supposed to be included in the next for the annual cost analysis. Okay, but since this is from the book, so in page 250, you can see the annual equivalent worth criterion. So what is this AE criterion? It says here, it provides a basis for measuring the investment worth by determining equal payments on an annual basis. Okay, here we consider the profitability of the project and distribute that to the different life. So in other words, if we are talking about P, W, and FW as measure of profitability, so we distribute this. That's why the AE criterion is the A. Can you still remember the A? Annual equal payments in chapter 2. But here, it is equivalent to the annual equivalent worth criterion. Okay? If PW and FW are measures of profitability, or that is the total profit of the project based on the investment is PW, based on the project balance at the end of its life, that is FW. Then AE is also a measure of profitability on an annual basis. Okay, take note. AE is a measure of profitability on an annual basis. So, annual basis. Now, in this method, all incomes or revenues and disbursement or cost are converted into equivalent uniform annual worth. So, in other words, for example, for the total project, you have 1,000 profit for the total life of the project. So, you are going to distribute this in annual equal worth that is equivalent now to our AE. Okay, another concept for the annual equivalent worth criterion is that the AE, okay, by the way, what is the formula to get the profit? So we have the general formula, profit is equal to total revenue minus total cost. So that the annual profit is equal to annual revenue minus annual cost. Okay, so the annual equivalent worth criterion is the average annual profit of the project. Okay, it says here on an annual basis. Only that you know, in real life, the project may not have the same profit every year. Maybe this year, maybe 1,000, maybe next year 5,000, something like that. So different. But what we are doing here is we make it as uniform, distributing it as uniform throughout the years. It is just like average. So it is an average profit, average annual profit. So we call that as the annual equivalent. So how are we going to compute for the annual equivalent? Okay, here we need the present worth of the project. So for the formula, okay, we have here. So this is now the formula to get the AE. Okay, can you still remember what is our PW in this example? So our PW is 1,546,571.23. Okay, can you still remember this formula? This is the A of P. Okay, remember this one? A equals P. Okay, we have I, 1 plus I raised to N over 1 plus I raised to N minus 1. Okay, that is the same. That is the same as the formula of the A of the P. Okay? So here, what we have, if our PW is 1,546,571.23, so our annual equivalent is 371,734.42. That means to say, on the average, the profit of the project per year is 371,734.42. So as if this is the profit every year on the average. Okay, so that is annual equivalent worth criterion. Now another important thing here for AE is that if you are comparing two or more projects, but they do not have the same N, like for example, project A has N equals 5, project B is N equals 7. Okay, in that case, they are not comparable in terms of PW or FW, unless we are going to compute or calculate the annual equivalent. But in terms of their PW and FW, we cannot compare because they do not have the same N. Okay, and what is the solution for that? If you want to compare the two projects, then get their AE. Okay. Now let's proceed to the rate of return, or we call this as ROR, rate of return. So what is ROR? Okay, in page 296, actually we have several definitions of ROR. So the first, it says here, the rate of return is the interest earned on the unpaid balance of an amortized loan. Okay, so what is the amortized loan? Amortized loan. How much is our amortized loan in our example? Amortized means we are computing the, for example, you are computing the annual payment, or every year, as long as you have not yet paid your balance, you are still paying the principal plus the interest. So we call that as amortized loan. If you avail of car loan from the bank, we call that as amortized car loan. That means to say every period you are paying something. Well, maybe it is monthly or maybe it is yearly, but it is amortized. Now, the rate of return is the interest earned on the unpaid balance of an amortized loan. Okay, take note that you loaned 1.8 million here. That is the, at the beginning, that is the unpaid balance. So you use that unpaid balance to come up with a Mazak multitasking machine, and that multitasking machine is earning while you are paying the interest for the unpaid balance. That unpaid balance is also bringing you, we call that as the earning amount of your investment. Okay, can you imagine that one? So for example, this is the loan, 1.8 million. So every year you are paying for the interest of the unpaid balance of that loan. Okay, while you are paying, you are also earning. Okay, you are earning interest also from your investment. So you pay for the interest of your loan, but you receive also the interest earned by your investment. Now, how fast the interest you earn is paying the unpaid balance. Okay, that's why it is called as rate of return. Okay, so that is the ROR. Now we have again the cumulative cash flow. Okay, you look at here. These are the unpaid balances. But while you are paying the interest of the unpaid balances, you are also gaining the benefit of your investment. So here, the rate or how fast your earning power should be higher than the rate of paying your unpaid balance. So that is the first definition of the rate of return. Another one is, it says here, the rate of return is the break-even interest rate at which the net present worth of a project is zero. Okay, So what is our MARR? Our MARR is 15%. And we know that at 15%, our PW is 1,546,571.23. That is our PW at 15%. Now, what interest rate will make the PW zero? Because if it is 15%, our PW is this one. Now, the question here is, what interest rate that will make the PW equal zero? So that is the rate of return. The rate of return is the interest rate that will make the present worth equal to zero. Okay. If we do it by calculator, actually, maybe we can spend maybe more than 1 day to compute, because that is trial and balance. So for the computation of the rate of return, you need your laptop, you need your computer to compute this, because manually it will take time, like more than 1 day. Maybe we cannot yet compute for the PW. Okay, by trial and error, by the way, with trial and error, we can identify the rate of return. Like for example here, if the interest is 36, here the PW is positive 14,406.79. But if we apply 37%, what happened? It became negative 29,453.54. So in other words, between 36% and 37%, there is what we call as ROR. Because between this, we have PW, which is equal to 0. So we need to interpolate again. Like for example, 36% is equal to 14,406.79. And then we have the ROR, that is 0. And 37 is negative 29,453.54. So you can do that, same as what we did with the payback period. Yeah, Excel sheet, yes. In Excel, you can compute it easily. Okay, so it is about 36 point something here. So you can compute this using interpolation and ratio and proportion to determine what point, okay, between 36% and 37% will make the PW 0. Okay, you can try that in Excel later on. So that is the same as the next definition. Actually, it says here, ROR is the break-even interest rate at which the net present worth of a project is 0. In Excel, you can compute like this. Okay, so the formula is IRR, and you need to identify that is B2. So just highlight this one, and it will give you a very accurate answer. So that is 36.324159. Okay, the longer, the more accurate. Why more accurate? Because it will make the PW 0. So you can apply here. So if you are going to use the IRR as the interest rate, your PW is equal to 0. So that is the meaning of the ROR. It is the break-even because that is the interest that will make the PW from positive to negative or from negative to positive. And the net present worth on that point is equal to 0. Okay, so The most popular, that's why we use the IRR. Actually, IRR is only one of the rate of return method. We have a lot. So IRR means internal rate of return. Because we assume, okay, where is the negative balance here? Okay, we assume that, okay, these are the balances. We assume that the benefits that we get come from the investment, coming from the unpaid balance. That's why it is called as internal. Okay, internally we get the benefit out of that unpaid balance. That's why it is called as internal rate of return. So the function in Microsoft Excel is IRR. You can try that in your analysis, in your assignment. You can do that one. You can do Excel. Okay, so that is the definition. And another rate. Okay, we use the compound annual growth rate, or CAGR. What is this rate all about? So you see, we use the tool to indicate the profitability of the project. Well, IRR or ROR and CAGR are also measures of profitability. But this CAGR and ROR, because they are rate, so they describe the rate, how fast. Okay, like for example, CAGR is the rate of return that would be required for an investment to grow from its beginning balance to its ending balance. So we have beginning balance, which is negative 1.8 million, and we have the ending balance based on the FW. So what is the rate from that 1.8 million up to 4 million? What is the rate? How fast? How fast the negative 1.8 million became 4 million in 7 years? So that is what we are defining here in compound annual growth rate. And we have the formula. We have the ending balance, that is the FW, divided by the beginning balance, that is the initial investment, okay, raised to 1 over n minus 1. So in our example, we have here, okay, we have FW, which is 4,113,910.22. And our initial investment is 1.8 million, and we have 1 over 7 because we have 7 years. So we have 12.53%. So that means to say, your 1.8 million grew by 12.53% annually until it reached 4 million in 7 years. So how fast the 1.8 million became 4 million in 7 years? So that is 12.53. Okay, so do you think this is a good one? So 12.53% is okay? Okay, look at the criteria for your analysis. Well, suppose you put your money, 1.8, okay, you borrow money and then you put it in the bank. And the bank rate is 15%. How much is your ending balance after 7 years? How to determine that? Suppose you put your money in the bank, you invested 1.8 million in the bank. That's why you need to use, okay, remember F equals P1 plus I raised to N. What is our P? That is 1.8 million. Okay, 1.15 raised to 7. What will be the answer? So for sure, your F, okay, we call this as expected F is bigger than the actual F, or the present worth. Okay, another thing is, yes, so it is 4.7 million. It is almost 4.9 million. What is the one that we computed for the present worth? It is only 4.1 million. So this is 4.1 million. So the expected future worth is higher. That's why here, the CAGR result is not that good, because the MARR is 15%, but the result of the CAGR is only 12.53%. It is lower than the MARR. So that is not a plus sign, okay? It is not a positive result. Because suppose if you just invested your money in the bank, you put your money in the bank, after 7 years, you will have bigger money, 4.8 million. That is the expected, while the actual is only 4.1 million. Okay, so that is for the GR analysis. Did you get that one? Why? Okay, why the CAGR is not showing a good point for the project? Because the expected F is well, that is based on the MARR. So the CAGR is less than the MARR. That's why the expected F is higher than the actual future worth of the project. Okay, do you have any question here? CAGR? What information you can get from here? Okay. So after this, for project acceptability, you can present the results in summary table. So here we have the criteria for discounted payback period. We have 3.5 for the criteria. It depends on the prerogative of the management if they can accept that payback period. But of course, some management will say, okay, we can accept if we can see higher returns of the project. Now, for present worth analysis criteria, it should be the present worth should be greater than 0. Well, it is greater than 0. That is acceptable. Okay, for the future worth. Okay, remember we analyze it in CAGR. So the future worth should be greater than the expected F. Well, here it is not that good because the future worth is less than the expected F. Okay, annual equivalence should be greater than 0. Well, that is good. And we have IRR should be greater than MARR. Okay, we have 36. MARR is 15%, so that is good. Okay, CAGR here should be greater than 0. Actually, this one should be greater than MARR. But of course, it is greater than 0. Okay, that is acceptable. And risk, it is very high. What is that 10%, Faisal? More than? Which one is more than 10%? CAGR? It is not 12.53%, while MARR is 15%. Okay, but anyway, CAGR is greater than 0. So that is good already. But supposed to be, that should be greater than MARR. Okay, so any questions so far for this summary? Well, here, so MAR minimum, no, it is 15, Faisal. Our MARR here is 15% in this example that we are using. Okay, any question on the result and how you are going to analyze? Now, you need to discuss about the criteria and the results. Like, for example, you will say that the project is profitable in terms of present worth analysis, or the project is profitable based on the present worth analysis and future worth analysis. And you can discuss like that. Okay? Now, that is for project acceptability. Suppose you have project selection. Project selection means you are going to select which one among the alternatives will be selected. Okay, here you are given 3 alternatives. Okay. By the way, you can do like this one if the fixed cost, the variable costs are given. Okay, so what are the things? Okay, for example, you are given like this data. So investment cost is the initial investment. And then we have estimated quantity to be sold per year. So that is according to the maximum capacity of the plant or the machine. Okay, so this is not this problem is not anymore related to the previous problem, the Mazak. So this one is not anymore the Mazak, but another problem, so that I can show you what is project selection. Okay, so we have 3 machines, for example, and the by the way, the MARR of this is 20%. Okay, so we are given the capacity of the machines, and then we have the selling price per unit, and then we have variable cost per unit. And then we have annual expenses considered as the fixed cost. So by the way, there are 2 components of the total cost. We have the fixed cost and the variable cost. The fixed cost, from the word fixed, that means to say whether you produce or not, you will pay the same cost. Okay, example of fixed cost, we have the rent of the plant, rent of the machines. What else? Sometimes we have annual advertising fee. So any cost that is fixed, that means to say it is not changing even if we change the quantity of our output. In contrast, we have the variable cost. Variable cost, from the word variable, it is changing depending on the quantity of output. That's why if you are going to increase your output, your variable cost will also increase. Okay, it is not the same as the fixed cost, that even if you are not producing, like for example in the plant, there is a shutdown. Well, you are not producing during that day, but still you are going to pay something. There are still costs that you are going to pay, or the company has a cost to pay. Like for example, the salary, how about the light, okay, electricity, and so on and so forth. So they are considered as fixed. Okay, we discussed already residual value. So suppose these are the given data. Okay, what is the first? For example, this is this problem entails new product or product selection or product expansion. Suppose you are selecting 3 machines for expanding your plant. Okay, so there are 3 alternatives for you to choose from. Okay, what is the second thing that you're going to do? You are going to make the project cash flow. So we have the cash in and we have the cash out. So what are the components? For example, for project A, what are the components for project A? What are the components of the cash in? Okay, why it is 46,500? Where did we get that? Okay, so we have here, we call that as revenue. So revenue is cash in. What is a revenue? Revenue is, that is price multiplied by the quantity. Or sometimes we call that as your sales. So we assume here that when you produce, all of the products that you are producing will be sold in the market. So for example, for A, the quantity, the estimated quantity to be sold per year, or that is the quantity of production, is 15,000. If the selling price per unit is 3.10, how much will be the revenue of the firm for alternative A? How much is the expected revenue? So we have P, price, which is 3.10, multiplied by the quantity 15,000. That's why your we do not have other cash in except for the revenue and the residual value. So what is 3.10? Okay, that is 3.10 multiplied by 15,000. Yes, so that is 46,500. So that is where we get the 46,500. Except for the last, because we added the residual value. So that is 46,500 plus residual value 10,000. That's why it is 56,500. So that is for our cash in. How about for our cash out? Okay, remember, take note that we have 2 costs here. One is fixed cost, 15,000. That means to say for all the years, we have 15,000. But we have also variable cost. If the production is 15,000, if the quantity is 15,000, and the variable cost per unit is 1, therefore that is 15,000 plus 15,000. That's why that's why our cash out is 30,000. So we assume that this is true throughout the life of the project. So we have 30,000 here, and get the net cash flow. So we have this net cash flow for project A. Do you have any question how to make the cash flow for alternative A? Okay, now this is for project B, same procedure. And then we have project C. So now we have the net cash flow for the three alternatives. We can now compute for, okay, we can now compute for the PW, FW, IRR, CAGR. Okay, so the computed one, so you can practice for this one. So we have the initial cost here, and then we have the annual cost that we are going to compute. But here we have already the discounted payback period based on the table. And then we have the PW, FW, AE, IRR, CAGR. Okay, so you know already, we discussed already how to compute those things. So you need to compute per alternative and then put that in a summary table. Now, the only thing that we did not discuss yet, we have the annual cost and we have the break-even point. The rest, that is the same as project acceptability. Okay, how to compute for the annual cost here. Let's do it for project A. Okay, we take the data in the previous slides. So we have investment cost, we have quantity, and then we have selling price per unit, variable cost per unit. Then we have annual expenses that is considered as fixed cost. And then we have residual value and useful, we have useful life or the life of the project. So the following are the things that you need to compute for getting the annual cost method. Now, there are several ways how to compute for the annual cost of the project. But here, we can use two. I will introduce to you two methods for computing the annual cost method. Usually, in accounting, you need to itemize like this. So you need to compute for the depreciation, and then put the annual fixed cost, annual variable cost, and the interest and capital. Now, what is depreciation? You can find that in your book. I forgot the page number. Okay, it says here, depreciation is defined as an accounting method of allocating the cost of a tangible or physical asset over its useful life or life expectancy. So that means to say, it is considered as a cost. That's why it is included in the computation of annual cost. But this is an accounting practice of distributing the cost of the tangible asset or the physical asset. If it is a machine, so we need to distribute, if the cost of the machine is 30,000, we need to distribute that to its useful life. So that means to say, we need to divide this in 10 years. But of course, for 10 years, it is affected also by the time value of money. Okay, so how to compute for the depreciation? So initial cost minus the residual value, and I'm sure you can still remember this. So this is the, okay, can you remember that one? A is equal to F, okay, I plus I raised to n minus 1. Okay, that is where we get the formula. So sometimes depreciation is not the formula for depreciation is not given because it is already same as the formula of the A if F is given. Okay, so we have initial cost 30,000 minus the residual value 10,000 multiplied by that factor. So here we have, okay, depreciation is 770.46. So whatever is the, okay, the result of your computation, so you put it here. And then we have annual fixed cost, okay, that is coming from here, 15,000 as well as the annual variable cost, that is 15,000 multiplied by 1, so 15,000. And then we need to put also the interest on capital. So interest on capital is initial cost or initial investment multiplied by the MARR, or multiplied by the interest rate. So that is 30,000 multiplied by 20%. So yes, 20%. So that is 6,000. Okay, and then get the sum. This is now the total annual cost for alternative A. So do that also to alternative B and C so that you can compare later. Now, another method. Okay, do you have any question here for a conventional payback conventional annual cost method? Usually, this is what they use in accounting offices. They use conventional. But for engineering economics, we have also another method. Okay, now the second method to compute for the annual cost is called as EUAC, or Equivalent Uniform Annual Cost. Okay, so here we convert the not annual to annual. Like for example, initial cost, it is not annual. It is a one-time cost at the beginning of the project, as well as the although residual value is not a cost, but it affects the investment cost. That's why we need to include that. And take note that residual value is also a one-time cash in found at the end of the life of the project. So the first thing that we are going to do is to convert the annual cost into equivalent annual investment cost. Okay, how to do that? We need to use the formula A of P. Okay, remember the formula? Okay, why P? Because initial cost is found at the beginning of the project. That's why it is considered investment cost is considered as P. So convert that into annual investment cost by getting the A of the P. Okay, so the result is 7,155.68. Okay, and then fixed cost is already annual, so you don't need to convert that to annual. Same as annual variable cost is already annual, so you don't need to convert that as annual. But residual value that affect the investment cost should be converted into annual equivalents. And since residual value is found at the end of the life of the project, we need to use the formula A of F. So we have I, we have 1 plus I raised to n minus 1. Okay? And since residual value is not a cost, it is a cash in. In the world of cost, it should be negative. That's why you can see here, it is negative. Why? Because it is not a cost. It is a cash in. And we are in the world of cost. So we need to invert, okay? Since residual value is not a cost and we are in the world of cost, that's why residual value here is in the form of minus, negative. Okay, so here, the result is also 36,770.46, which is the same as the previous computation that we have. In other words, you have the choice whether you use the conventional method or you are going to use the EUAC, because it will give you the same Okay, so that is for annual cost method. Now, okay, so we completed the table for project selection. Now it is time to analyze and to make decision here. What do you think? Which alternative you are going to select? Anyone? Which project are you going to select? Okay, for Abdurrahman, so you are proposing C. Based on, okay, let us see. Annual cost, it is not the lowest. Okay, for example, this is how you are going to analyze later on. If you look at the summary table, not all the indicators favor C. But for example, Abdurrahman want to present this as his choice. So he will tell the management, okay, I'm proposing alternative C. Okay, for Faisal, he said he is proposing alternative A. Okay, but for Abdurrahman, alternative C, there are indicators that doesn't favor C. Like for example, annual cost. For annual cost, it is not C, but it is A for the annual cost. For payback period, yes, it is. Okay, let us check. So for annual cost, it is A. For payback period, it is C. For PW, yes, it is C. FW, C. AE, yes. And then rate of return, still. And we have CAGR, highest. And break even, what do you think for the break even? For break even, what did we say? Is it the higher or the low? Is it the highest or the lowest? It is the lowest. Why lowest? Why break even should be lowest? Because if it is the lowest, okay, at low quantity, you can already break even. Unlike if, like for example, you need to produce more in order to break even. So it is better if it is lower to break even than higher to break even. That's why we select the list. And of course, we need to include the risk. I think you need to compute 2.5 out of 10, and then 2.8 out of 10, and then 2.1 out of 10. Okay, they are almost the same when it comes to risk. Okay, so regardless if you select A or C here, but if you are going to select A, if you are going to select C, you have smaller things to justify. You will just justify this. Okay, you need to justify the cost and the break even. So are you willing to take this project, alternative C? You need to justify the annual cost because A is lower. But when you say, what is that one, Faisal? Quick payback? Yes, the faster, the better. Okay. Now, if you select also A, well, that's fine, but you need to justify other things. Like, for example, you need to justify PW, it is not the highest, FW, it is not the highest, but make some justifications. So here, it is not only that you see, okay, there are more favorable indicators for alternative C. You cannot just say like that. You need to justify why you need to select C, despite that it is not the lowest in terms of cost and it is not the lowest in terms of the break-even point. Okay, so you need to justify. Well, before I forget, in terms of cost, because this is where, okay, where alternative C did not get it. Okay, now, lowest is A, and it has the lowest initial cost. Lowest annual cost and lowest initial cost. Now, in terms of other things here, for example, we have C. If you are going to justify C later on, so we have 50,000 as annual cost, and it has also higher initial cost. Now, if you are going to select C, you are going to add how much? Every year, how much you are going? In terms of initial cost, you are going to add more. You need to add 10,000 more in the initial cost, and on the annual cost, you are going to add how much? That is 5355.68 minus 36,000. Okay, it is just like 13,000 every year. So this is the additional okay, you got it? If who's going to Mubarak and I think Abdurrahman and Mubarak is going to select C, they will justify the additional 10,000 for the initial cost and 13,000 annual cost, additional annual cost compared to A. How are you going to justify this? Okay, one thing for justification of this one is, okay, you are going to select one here. Is it the mostly it is the, normally it is the AE part. What is the benefit here over C over A? How much is the difference when it comes to AE? Remember, what is AE? That is annual equivalent, or that is the equivalent annual profit of the project. Okay, what's the difference between C and A? Okay, we have 16,244 minus 6,514.78. Okay, so Ali is correct. Okay, now what we will do with this? Okay, we are going to take, okay, 10, like for example, annual cost, that is 13,585.22 divided by sorry. It should be 6,514.78 over 13,585.22. Okay, this is what we call as rate of return on additional cost. Okay, that is 0.4795 multiplied by 100, that is 47.95. Okay, this is what we call as ROR on additional annual cost. Rate of return on additional annual cost. So the ROR on additional annual cost is 47.95%, which is higher than MARR. So with that result, you can justify selecting C. If the cost is the issue here, so the rate of return on additional costs is higher than the MARR. That means to say, even if the cost of C, annual cost of C is higher than annual cost of A, it will justify the annual profit of the alternative C. You got it? Again, 47.95% is higher than your MARR. That means to say, we can go with higher annual cost because the annual profit is more higher in terms of percentage. So it justifies the higher annual cost. The annual profit justifies the additional annual cost. Why we are doing that? It is because the annual cost of alternative C is higher than that of A. So we need to look at how we can justify that. Because if we say, okay, we will recommend alternative C, but you need to justify the higher cost. Okay, so what we will do, we get the difference of the annual cost as well as the difference of the annual profit. Remember, AE is the annual profit. Is the additional cost or the difference in cost 13,585.22 can be justified by additional profit of 6,514.78. Okay, get the ratio. No, you need to justify PW. This one, the justification is only between the cost and the profit in here. Because the only question for C is the annual cost. It is higher than A. That's why we will see if the profit of the project can justify the acceptance of additional cost. So if it is greater than MARR, then fine. It justifies the higher annual cost. So that is one way of justifying. It is called as rate of return on additional annual cost. Because if you are going to select C, you have 13,000 more to pay every year. Are you okay with that? Higher? You are going to pay higher? Well, we will look at the profit also, because according to the fundamental concepts of engineering economics, it says, okay, we are willing to take the higher risk if the return is higher. Okay, that is the same as, okay, we can take higher cost as long as the profit can justify the cost. Yes, if the return is okay, in this way, that is ROR, rate of return. So it is the return. It is higher than what we are expecting, minimum attractive rate of return. So in this case, we can select C. Okay, we can find, we can also, if we cannot make for AE, you can find, like, for example, the PW, you can also use that, or FW. But normally, it is about the profit, between the profit and the cost. Okay, so do you have any questions so far? So that is how we evaluate projects. What is important here is we can save the resources of the company. Remember that resources are limited. That's why this is called as engineering economics. It is an economic subject. It is because our objective here is to see to it that the resources of the organization or the company is spent well. When we say spent well, we invest it in a right project so that the benefit that we can get from the project will be higher than, than the cost. That's why we have what we call as cost benefit. The benefit should be higher than the cost. And we are not going to waste the resources of the company. We can select the best project so that the resources that we used will be more valuable, will be in terms of worth. It will have higher worth. Because if we are not going to analyze, we are not going to conduct this analysis, maybe we can just select any project that we want. But in terms of benefits, that project will not give as much as the other alternatives. So we need to identify the alternatives, and then we are going to select.